Hi, this is Mrs. Vrobel. This is Analyzing Data Part 2. Just give you a heads up, I'm recording this during a thunderstorm and hopefully it goes well. Here are the following objectives for this part of the chapter. You're going to accurately describe large and small numbers using scientific notation. You will also precisely determine the number of significant figures in a group of numbers. You will also correctly calculate the number of significant figures with addition or subtraction or multiplication and division. Okay, so like I said, this is review. This is something that you've covered in middle school. And here we have 1 billion. So in order to get the scientific notation, I'm going to count to the left of the decimal. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So notice for the exponent, I used the number 9 to describe how many times I moved the decimal. And I put the decimal right after the non-zero number. We can go the other direction. So here we're going to the right. So I'm going to go 1, 2, 3, 4, 5, 6. It's always to the right of a non-zero number, and here is the non-zero number. Notice I have to include the other non-zero numbers. And because I went to the right, I use an exponent of a negative 6. So when you go to the left, it's positive. When you go to the right, it's negative. Okay, why do we use significant figures? Well, in science, you're going to find that you're kind of guesstimating a number of digits, okay? So the significant figures mean that you know exactly those numbers. The insignificant figures are the ones where you're not totally sure. And here's a ruler where we know the known digit, which is 5. That's pretty obvious. We can see that no problem. And we know that there's a 0.2 right here. However, that 0.03, we're not totally sure if that is significant. So we have to treat it a certain way. Okay, so here are some rules. All non-zero numbers are significant. So here we have a series of numbers, and notice there's a decimal after the very first non-zero number. We have to count all of these non-zero numbers as significant. Now you could have a different situation where there are zeros in between non-zero numbers. When that happens, they are significant. So notice how we have a decimal, and then after the decimal we have zeros, then a non-zero number. You have to count all of these numbers as significant. So therefore it's 7 significant figures. Okay, a third rule is leading zeros. What does leading zeros mean? Well, you could have, and this is the challenge for a lot of students, these leading zeros here are considered just placeholders. So as a result of it, only the last 3 non-zero numbers are considered significant. So if you have a decimal place and you have 0 numbers ahead of non-zero numbers, they are just placeholders. Okay, next, trailing zeros. Trailing zeros are considered only significant if they have a decimal after them. So, if you have a million and you just have that 1, those zeros that come after it are not significant. Now, here's a situation where we have a decimal. Okay, these 3 zeros here are considered non-significant. However, there's a trailing 0 after a non-zero number. That would be considered significant. Okay, when there's no decimal point, they may or may not be significant. So let me show you here. This is what I was referring to. Here we have 6 million, okay? The 6 is the only significant figure. The rest of these are just placeholders. Now, if I put a decimal at the end of this, I would have to count it as significant, and that would be 7 significant figures. Here we only have 1. Okay, now counting numbers. So if you're counting your fingers, if you're counting how many cupcakes you have in a box, those are considered unlimited significant. Also, if you have exact standards, like we know a mile is exactly 5280, they are infinitely significant. So we don't have to count them as significant. We know that they're unlimited. Okay, um, for scientific notation, okay, you have what we call the significand. So here we have an example of scientific notation. Notice that the 10 to the second is not considered significant. That is just a placeholder, okay? That's why we have three significant figures. Okay, rules. So I told you there were two sets of rules here, adding and subtracting, okay? Now, with adding or subtracting, what I usually tell students is I look at the number of decimal places. So that's got 2, that's got 3, that's got 1. Okay, notice how our answer only has one decimal place. And it doesn't matter how many numbers are to the left of the decimal, all that matters is the decimal places. Because this number had only one decimal place, it determines the answer, and the answer can only have one decimal place. Okay, division. Now division's much different. With division or multiplication, you need to look at the total number of significant figures, okay? This has 3 significant figures. This has only 2. And notice it's 2 because it has a decimal right next to the 0, okay? The answer can only have 2 significant figures. Now, if you were to do the math for this, you would probably get an answer that is greater than 1900, okay? What we do is we round up or round down depending on how close we are to the placeholders here, okay? And notice also that this is inches squared, okay? Just a clue to what you're going to have to deal with. Okay, so in summary, scientific notation is written. It has a coefficient between 1 and 10, and it's multiplied by a power that is base 10. Significant figures are also determined by the location of the 0. Remember, if there's zeros in the middle of non-zero numbers, they are significant. When adding or subtracting figures, you got to look for the least number of decimal places, and that will tell your answer how far to round for that. And then lastly, when multiplying or dividing, the number that has the least amount of significant figures is going to tell you what your answer should be.